The most important aspect of the Dataguard is network transport. And if the undersized or improper configuration may lead to the redo transport issue, and production may show you the log sync weights, etc. The following parameters may be tuned if extra performance is required. Before and after testing should be performed to check the results prior to any live implementation. Pay attention to log_sync weights in AWR. Properly configure TCP send/receive buffer sizes. Gains have been realized when setting send and receive socket buffer settings up to 3 times the BDP. BDP is product of the network bandwidth and latency. Socket buffer sizes are set using the Oracle Net parameters recv_buf_size and send_buf_size, so that the socket buffer size setting affects only Oracle TCP connections. The operating system may impose limits on the socket buffer size that must be adjusted so Oracle can use larger values. For example, on Linux, the parameters net.core.mem_max and net.core.mem_max limit the socket buffer size and must be set larger than recv_buf_size and send_buf_size. Increase SDU size. With Oracle Net services, it is possible to control data transfer by adjusting the size of the Oracle Net setting for the Session Data Unit, SDU. Oracle testing has shown that setting the SDU to its maximum value of 65,535 can improve performance for the SINC transport. You can set SDU on a per connection basis using the SDU parameter in the local naming configuration file, names.ora, and the listener configuration file, listener.ora. Or you can set the SDU for all Oracle Net connections with the profile parameter default_SDU_size in the sklnet.ora file. TCP protocol stack. To preempt delays in buffer flushing in the TCP protocol stack, disable the TCP NAGL algorithm by setting tcp.nodelay equals yes in the sklnet.ora file on both the. How to measure network latency for Oracle Dataguard replication. Oracle Dataguard replicates data from the primary to one or multiple standby databases for high availability and disaster recovery. The decision to transfer the redo synchronously or asynchronously depends on your RTO and RPO. Synchronous redo transport provides zero data loss and lower recovery time. But your application needs to wait until the data is written on the standby site on disk, SINC, or in memory, fast sync, before getting the acknowledgement about the commit. The additional time needed mainly depends on the network latency for fast sync, and additionally on the write to disk time for SINC. So the question arising is, what is the minimum latency needed to have no or minimal impact on application performance for synchronous replication? The answer, it depends. Each application will have a different tolerance for synchronous replication. Differences in application concurrency, number of sessions, the transaction size in bytes. How often sessions commit, and log switch frequency, result in differences in impact from one application to the next even if round-trip network latency, RTT, bandwidth and log file write-I/O performance are all equal. In general, Oracle sees customers having greater success with synchronous transport when round-trip network latency is less than 5 milliseconds than when latency is greater than 5 milliseconds. Testing is always recommended before drawing any specific conclusions on the impact of synchronous replication on your workloads. Ping. Ping is an easy-to-use utility that is available for virtually all operating systems and might be the first thing many people think about for measuring network latency. Ping C3 IP address. However, even though ping gives you an RTT, the primary use of ping is usually to test the reachability of a host. Latency measurement via ping is not significant for Dataguard replication as the mechanism used is different. ORAT test. Oracle designed a particular utility called ORAT test specifically to help customers assess network resources used by Dataguard redo transport. Golden Gate RMAN backup and restore, migration, Dataguard instantiation, and database remote clone. You download the utility, jar file, from Oracle MOS No 2064368.1. Hashtag primary. $LSL/home/OPC/ oractest.jar. Hashtag standby. $LSL/home/OPC/. orictest.jar. orictest.jar can be run in client and server modes. On the standby host, the server, mfrod2, execute the following command. Java jar orictest.jar server _name _ IP port equals port _ number. On the primary host, the client, mfrod1, you have three options. 1. Mode equals async for async redo transport, measuring network throughput only, as latency to the standby does not impact the application performance. #async. Java jar orictest.jar server _name _ IP mode equals async duration equals 100s interval equals 20s length equals 8k port equals 1521. 2. Mode equals sync and write for SANC redo transport, measuring network throughput, latency, and write time to disk. #sync. Java jar orictest.jar server _name _ IP mode equals sync duration equals 100s interval equals 20s length equals 8k port equals 1521 write. 3. Mode equals sync without write for fast sync, measuring network throughput and latency, but without writing to disk on the standby, reducing the overall round trip and improving application performance. #fastsync. Java jar orictest.jar server _name _ IP mode equals sync duration equals 100s interval equals 20s length equals 8k port equals 1521. Network latency, mainly impacted by physical distance, is crucial for Dataguard synchronous redo transport. Oracle provides a particular and easy-to-use utility called orictest for measuring network latency and throughput.